Eric Meyer, you guys. I mean, it's a real honor to follow. Yeah, come on, Eric, Jeffrey, some of the real uh, sort of founders of this industry and so many of the practices that we all follow. I've learned a ton. It was 17 talks already, and my brain is bursting, not just from that, but from talking to so many of you and hearing your ideas. So I'd like to share some back. And what I'm going to do for the next hour here to close this thing out is to talk a little bit about how to approach design work when you're working with and unveiling awesome new technology. For example, some of you might remember the Juicero last year. Anybody? Yeah? All right. This was an internet-connected juicer, and it was pricey. It was $400, but friends, well worth it. Their amazing innovation was that it didn't actually squeeze juice. It just squeezed these prefab juice packets. Except it turned out you didn't need the fancy juicer to squeeze the packets. You could just do it by hand in exactly the same amount of time, exact same result. Either way, you were just drinking the stuff out of the packet. But hang on, there was some value to this. The machine could read the barcode that was printed on each juice packet to check whether the contents had expired. Although the expiration date was also printed on the back of each packet, but still. So look, this was an expensive kitchen gadget, internet connected, but solved no problems and did no work. And it turns out that this was actually not a new invention. There's a long history of BS in designer juicers. Philippe Starck's juicer just makes a mess when you try to use it, but it's okay. Starck says that he never designed it to juice lemons. It's to start conversations. Well, thanks. I guess that explains it. Oh, Phil, you minx, you punked all of us, didn't you? So this is self-serving, when I believe our job is to serve others. This is the ego of the designer, and often we see it in us as technologists, too, the enthusiasm for making the thing rather than crafting the service the thing might do. The kitchen is full of stuff like this these days. A Wi-Fi-enabled kettle, friends. A Brit named Mark Rittman owns one of these, and he set about trying to make a cup of tea with his new Wi-Fi-enabled kettle. But the kettle encountered a little network trouble, and it turns out that it couldn't connect, and so it asked him to recalibrate the thing and sort of do a little bit of network jiggering. And so 3 hours later, the kettle had sabotaged his Wi-Fi router, and the kettle had now slipped into some sort of unknown nether region, some unknown corner of his network. So Mark is indefatigable. He's port scanning the network here in search of his kettle. And finally, some 10 hours later, he got the thing back online and working, but then his smart lights cut out because they needed a firmware upgrade. Now, friends, as you might imagine, the internet was not sympathetic to him and his kettle. Or maybe more to the point here, yeah, that's all right. Apologies for the language. It's like you can't account for those Brits. All right. Fast Company used these words to review a connected toaster oven, but I feel like you could substitute them for just about any kind of overreaching products and services right now. Automated, yet distracting. Boastful, yet mediocre. Confident, yet wrong. We sort of want that left side, but we wind up with the right side. Right? Jeffrey started off this conference by calling stuff like this pretty garbage, and Kate O'Neill cautioned us yesterday to not to give absurdity a chance to scale, and yet we all too often see that and feel it as consumers, and in some cases, we have to admit we've perpetrated it as designers and developers, right? Since we're here, it seemed like a good thing to bring out this quote. It's fun to do the impossible. But as Christina said at the beginning of the day, nobody cares what you think is fun. It's good to do the impossible thing that actually helps the people that we work with. The stuff that excites you as a maker, though, isn't always the stuff that's meaningful to the people who use the things that you made. So what I want to talk about today, and particularly in the light of machine learning, is how do we use technology the way that it wants to be used, in other words, the way that it actually works and that it can be helpful, but also in a way that adds meaning and that can amplify human potential, that can help us be more of the best parts of ourselves, do more of the best things, rather than perhaps sort of helping us or to really more infantilizing us rather than empowering us. So the answer to a lot of this stuff, as with so many things, if you read the tech press, is something, something, something machine learning. That's the answer to everything. And look, machine learning is actually a really sort of powerful technology and something that we can use in small ways, as we're going to be looking at over the next few minutes. So I don't want to diminish it. I do think that it's sort of this powerful buzzword along with the even buzzier artificial intelligence. But it is something that's starting to get some real traction. MIT and Google did a survey a few months ago of 375 self-described innovation-driven companies, not necessarily technology companies, from all kinds of industries, but that consider themselves innovative, and found that 60% of them are already implementing machine learning in some way, and another 18% planning to get started. So that's a really big number, right? And we see them using it in a whole bunch of different ways to analyze documents for either better searches or to understand the sentiment or emotion behind them for things like customer care, image recognition and classification to get new kinds of data out of documents, images that stuff was already locked up, natural language processing, both through speech and through text, to understand the meaning or what's actually the intention of these words in these documents. But I think a larger way, too, is machine learning is the oxygen that's feeding all of the emerging technologies right now. So it's the thing that's behind speech and camera vision and augmented reality and predictive interfaces and all this stuff that's happening right now. And you might be looking at this and being like, well, man, it's almost 80% of companies that consider themselves innovative are getting started, and where does that leave me? I know what you're saying. You're saying, but Josh, I can hear you. Josh. We're not data scientists. We're not Google. We don't have those kinds of resources to do machine learning. We don't even know where we'd start. We don't even know where we would put it if we did know how to do it. We're not a machine learning company. Or sort of put another way, I think we feel this way a lot of times when a new technology is coming around. It's like, and this is why we come here to places like this. I guess I'm supposed to know how to do this. This seems like it's the thing, but I don't. I want to tell you something that I hope makes you feel a little bit better, is that especially with this stuff, we are all figuring it out. Machine learning really sort of started to hit its stride to become effective and available almost 5 years ago now. And that's when you started to see some of the larger companies bringing it into their products. But we're still figuring out what it's good for. What is the grain of this new technology? What does it want? And how can we put it to use in effective ways? And really what I'm talking about there is, how do we think about machine learning as a design material? Just like HTML and CSS are design materials, just like great prose and copywriting is a design material, just like dense data can be a design material. And like any design material, it's important to understand its texture, not only how it can be used, but how it wants to be used. How do you use it to construct something in the way that it uniquely wants to be used? So that's what we're going to look at here, is sort of these 4 questions. What's it for? How do we work with it? What is its grain? Again, that idea of its texture. And how does it change us by using it or by working with it? And I would argue these are great questions to ask for any new technology, any new technique. These questions ask, what does the technology offer us, but also what does it require of us? I'm going to try to touch on both of those things. So let's get started just to look at, what is this thing for? How is it relevant to you and me and our everyday work and the products that we're already doing? Or another way to put it is sort of like, why should we use this anyway? Why should we team up with machine learning? In a nutshell, the answer is that it offers us this opportunity to ask, what if we could detect patterns in anything related to our customers or product and act on them and do something valuable? And really, there's sort of these 5 categories of ways that machine learning can bring value. And I'm going to walk through each of them and give you some examples. And a lot of them are going to be sort of small and familiar in the way that we use products every day. One of them is in Slack. If we look to Slack for an example of recommendation, Slack launched a feature a few months ago for big teams that helps you find people who talk about certain topics. So this is machine learning that helps you find experts in your organization. You need an expert on hiring process? Turns out Isabella here is your go-to. And so this is recommendation, really simple, very familiar to us. It's a ranked list of documents that match a specific context or concept, right? It's closely related both to classification, which I'll discuss in a bit, but also to prediction. So let's take a look at that. Predictive keyboards, another example of just everyday machine learning, right? The statistically most likely next word showing up above the keyboard. So it's a simple intervention to speed the error-prone task of touchscreen typing. That's prediction, right? Based on historical data, here are the things that are most likely to happen next. So recommendation, prediction, classification, Google Forms, which is likely familiar to many of you. When you add your questions, when you build your survey, you have to choose the format of the answer that you want. And the default is multiple choice, radio buttons. But there are a lot of options here. And they've made it as simple as they could, but it still takes some time and thought to figure out. But look what happens when you start typing the question text. How satisfied are you? Maps to a linear scale. See, it just switched to a linear scale. They added a little machine learning to the mix to look at your question and classify it to a specific answer type. So which of the following apply? That maps to checkboxes. So just a convenience, a bit of intelligence to make that process easier. So classification is human-generated categories, or the way that we think about it, and then we train the machine and give it examples of, in this case, phrases that match those categories, and then the machine takes over and figures it out for itself, finds those patterns and maps similar phrases into those categories. You might be looking at this as like, this doesn't seem so fancy. This is not, Terminator. This is not the machine, the singularity that's going to take over the world, and that's right. I think that the first thing that we need to do right now is to recognize that a lot of the uses of machine learning, in fact, some of the most promising ones, are really casual uses of it. If you look at just how mundane some of these examples are, machine learning can be, I think should be, part of your everyday toolkit. You drop in machine learning as casually as you'd add JavaScript to a page. That's where we're headed in the really near future, and some companies are already doing it. Mobile defined the last decade of digital design, and I would say that machine learning is set to define the next sort of plateau that we're going to step up to have to learn. So we need to get as comfortable designing for the algorithm as we've become for the small screen, and understand that sometimes that's just like little bits of interface that go in there. It's an enhancement that's becoming part of the everyday for a certain class of companies right now, and for everyone very shortly. So it's time to get started with it. So you could say these casual uses of machine learning. What I like to say, you can quote me on this, friends, is let's sprinkle a little machine learning on it. How do we have this sort of existing interface, and how do we kind of add a little bit of intelligence to it? It doesn't have to be a big, fancy, artificial intelligence something to start using this stuff. In fact, in many cases right now, machine learning is best deployed in small interventions that solve critical tasks in any given activity. And those critical tasks may not be gigantic tasks. But there are bigger opportunities, too, for the machines to sometimes take over that entire task, like writing simple news stories. So the Washington Post, the newspaper owned by Jeff Bezos, has bots writing simple, sort of wire service-style news articles. And it takes data and it classifies it, mapping those classifications to phrases inside templates. So, for example, in a political campaign, say a state house race or something, if the data shows unexpected results versus recent polling, the system might classify that as an unexpected result and pour in a phrase like a stunning reversal of fortune, which you see here in the bottom paragraph. So it's got some pretty good gates around it, but it's taking the data, figuring out how to classify it, attaching phrases to it, and pouring it in. And so their system is called heliograph. They use it for stories with simple narratives, these sort of horse race stories like a political contest or sporting events. They first used it in the Olympics a few years back. And they're actually sort of starting to use it to kind of write articles. The AP doing something very similar too. Classification. What happens when we bring sort of simple classification into the work that we do. Another classification, for example, for people who use a lot of Post-it notes. This is an example of this sort of super simple camera vision problem of classification. You know what happens, right? We have all these Post-it notes, and eventually someone has to take a photo of the Post-it notes on the wall, and maybe they wind up someplace, maybe they don't. Well, what if you could just bring them in, take a picture, and import them into a digital format for saving, right? Or combine that with handwriting recognition to get that data into editable or machine-readable form. So Post-it, the 3M company, they've got an app that does this, and it's just sort of, it's a very simple computer vision problem. Find colored blocks. Those are Post-its. Pull those in as graphics. And again, the next step is to run those through a handwriting API. So clustering is interesting. That's classification, where we're taking these sort of human-identified categories and training the machine for the content that matches those categories. Sort of the next level thing, and this is where deep learning has been really interesting in the last few years, is where you basically say, hey, machine, you figure out the categories. And you sort of run an analysis on it, and it finds and groups things. And those things could be people, their purchase histories. It could be concepts or ideas and documents. Anyway, it finds all of their different affinities and differences and clusters them together into its own categories. It says these things are different from the norm in these common ways. That's a cluster. Here's another group that's different from average in other ways. That's another cluster. So it's classification, but done by machine logic, not human logic. I think what's really sort of exciting and a little mind-bending about it, and we'll talk about why in a few minutes, but it means that the machines can see things that we wouldn't, both because of the scale of the data that it can look to try to find patterns, but also because machines tend to find patterns that we're not tuned to. So it's a way to identify ways in which things depart from the normal or the average. It's how you can identify fraud or crime or disease, right? These are things that are sort of like aberrations from the norm. Spending in your personal account that might be outside the norm that you might want to look into. So it's groups of data points that sit outside the norm in an interesting way. And that also means that you can use it to identify clusters of products or customers or people by behaviors or associations that might not be immediately apparent or obvious. Anyway, it's basically a way to say, hey, this is interesting. This doesn't look like the usual everyday humdrum. So it finds it in visible patterns. So I'll show you an example that combines unsupervised clustering like that with content generation. And you begin to get glimmers of something that feels a little bit like creativity. Douglas Summers Stay is a researcher who's interested in artificial creativity, and he created a wordplay generator. So you give the system a word or a phrase like rocking chair, and it comes up with a 2-word rhyming description of that thing. Knitter sitter. Or give it Star Wars, and it comes back with droid overjoyed. Right? So and there's a ton of these things, right? So it's got all these things it can generate. It's a system that's based on semantic vectors. So it organizes words that have strong associations. It clusters them on its own. So here it finds those words and then runs them through a separate algorithm to find the pairs that rhyme. So, I mean, it's sort of interesting. It's like, wow, this is pretty good. This is going to give Will Shortz a run for his money, the sort of the puzzle master guy, right? This is like pretty clever wordplay that this thing is able to do just by giving it a huge trove of words and letting it find those associations. So that's a fun example, but the really sort of powerful stuff, after we look at some of these 5 categories, the powerful stuff personally that I think happens is when you sort of start to point these things, these abilities, at the kind of work that we do. So you probably recall QuickDraw. It was a Google experiment, gosh, what, maybe a year and a half, 2 years ago, to identify sketches. And so, the way that it works is it'll say, draw a mountain. And you sort of go, and then it starts to identify it for you. It says, oh, I know, it's a mountain. And then it says, you draw a calculator. And it sort of shows you what it's thinking at first. It says, I see a square, I see a triangle, elbow, dishwasher. Oh, it's a calculator. Before you even finish, right? Draw a hamburger. Okay, it's a shoe, it's a hot dog, it's a hot tub, I see bread, it's a hamburger, right? It's like it sort of figures it out, but it's sort of this manic kind of thing. It's like playing Pictionary, right? Or it's like this one. I see a nose, I see a potato, I see a peanut, it's flip-flops. You guys, that is so not a flip-flop. right? I drew that, I'll fess up to it, but that is like so not a flip-flop, and yet it knew it was a flip-flop. And so we look at it, you can investigate it a little bit. It lets you explore what's going on. It's like you asked to draw flip-flops, you drew this. It sees a little potato in there, it sees a little bit of bread, but it also, it will show you, here's some ways that other people drew flip-flops. And you start to see some commonalities in these sort of symbols of the way that we commonly understand this stuff. It's also not just the shape that it's identifying, but it's the way that it's drawn. It's where do you start, which direction do you go? It's tracking the way that you draw, as well as the shape itself. So if you're starting to be able to have the machines be able to understand these squiggles, these shorthands, this notation that we use, well, man, we use notation a lot in the work that we do. I'm gonna take you back a few years to an app, an iPad app called Adobe Proto from, gosh, I don't know, maybe 2012, something like that. Adobe made it for designers. It was later replaced by Adobe Comp, a way to quickly comp UI. But I think that Proto was really clever in its use of notation, in this case, for drawing wireframes. So again, this is from maybe 5, 6 years ago. It was really prescient use of pattern recognition that now we're seeing everywhere. So again, a lot of these sort of ideas for this stuff isn't new. It's been here for a while. We've just been a little slow to adopt it. So we can look back at the last decade even of interaction and find some signals for how we can use this. But let me show you how this works. The idea is basically that you have these familiar notations that you can put. It's a little squiggle. I'm gonna put in some text, a heading. That's how I do a navigation bar. Maybe over here I want a video. What about an image up in here? A couple columns of text, I'll just draw those in. Then you tap a button and it would export as HTML. It was terrible HTML, but it was HTML, right? And what it was doing was just, again, sort of like we were seeing a little bit in the much more sophisticated sketching app that Google came up with, is that it's just understanding these common symbols. And we use a pretty small set when we're doing stuff like this. It's a pretty closed domain. Of course, we're more likely to start those loose sketches on paper like this, and so we're right now seeing a wave of services aimed at capturing those too. Microsoft just recently released an experiment, I think it's best to call it, called Sketch to Code, where you can upload your photo of a paper wireframe and it will try to do it in HTML for you. Similar one called Wizard, UI-Zerd. It's a little tricky. You can say it any number of ways. I'll leave it to you to decide. I've decided Wizard. All right. So the idea here, too, is same thing, is that you can go in and it invites you to take a picture, upload your wireframe. So you go in, you can do that. I drew this super simple thing, an idea for an inbox mobile app, really easy. And then, it takes like a minute or so, 30 seconds maybe. You can go over to your desktop and you'll find that it's already there. There's my sketch on the left. And then on the right, you can see what it's put together as sort of a comp. But it's not just a static comp. We can go in here, we can grab a sketch file, we can grab HTML, and we can sort of go and we can take a look. Let's go into the Finder and open that up. That's the first folder there, the sketch file. Look, there it is. It's stuff that we can actually edit. Let's get in, we can see, we can get in there and change the text. Regular old run-of-the-mill sketch file, drag stuff around, look at it. And so the images, the checkbox thing, it's all symbols that it's got under the hood. And in fact, if you drill into it, into the symbol library, which we can do by looking at this input thing, you can see it's just got sort of a handful of files. This is still an early product. It's fairly brittle. It only has a handful of kind of symbols that it understands and maps to. But it's working pretty well. And when you can also look at the HTML that it creates. You can see, very sort of simple page, but it's pours it in to sort of into a fluid design. And if you look at the markup, it's actually pretty good markup. I mean, again, it's this very sort of simple setup, but it's pretty clean. It's got label tags in there around the checkboxes. It's doing all the right stuff. Of course, the thing is that it's a nice start. And again, it's pretty brittle. It's not, you're not going to be able, it's not going to keep up with you on a lot of stuff. But it's a glimmer of some of the possibility here. But what if the system was tuned specifically to your brand and your site and your coding style? What if it knew the way that you sketch the design patterns that you use all the time? What if it knew your design system? Airbnb put together something like that in a hackathon. It took about a day. They built a machine learning system to map sketches to patterns in their pattern library. So it's like basically they made squiggles, put it into a classifier, and said this squiggle is this design system pattern. You know, design systems are meant to establish a standard to be shared among people using that common vocabulary, that common language that Jasenia and Una and Brad talked about in design systems yesterday. If you've established that language, that shared language, why not share it with the machines too? Maybe add the symbols and notations that you already use to that mix. And speaking of vocabulary in that case, maybe you don't even need computer vision for this at all. Maybe you could just say it out loud or send an email to the system to get it to generate a working prototype, or at least a scaffolding of a design. Maybe we can skip formal wireframes and get right into the browser with something like this, like Dan Mall was talking about yesterday, at least when we're using patterns that have already been established. No wireframes. Now, that might have some of you saying, you know, hey, wait a sec. That's my job, that wireframe thing. That's what I do. But look, hopefully your job is really more than about drawing wireframes or adapting the same code over and over again from the same sketches if you're a developer. You know, that's sort of the rote stuff. That's the stuff that we're doing, the clerical work, in a sense, where we're actually thinking, the real work is thinking about what is the right pattern to use? What is the goal of this page? What is the right way to assemble these in a useful way? And I would say that that adds up to things that are like this. When we're looking at a lot of the work and documentation that we do, you're more than this. Your job is more than this. This is the common denominator descriptors for all the applications that we've looked at. The tasks the machines are best at tend to be time-consuming and repetitive and detail-oriented and error-prone and joyless, and you're more than this. These are not jobs we relish or really that use our best skills. But the robots, they love them. They're great at them. So our jobs will change. Some tasks will disappear from them, and that's not new. And often we do it ourselves. Developers, you're constantly automating stuff like this away. You grunt, you yelp, you belch. Aaron, talking about design ops just now, talking about taking care of all the overhead and friction that goes around actual designing. What are the opportunities for machine learning to do that work? And really the whole context is here. And this has been sort of true ever since we sort of got sensor-based stuff, our phones, when we started to use them to use Shazam to identify music or to use Google Translate to do live translation. How can we minimize input, the input that we have to do, that we have to give, let the machines do it, and maximize the value? Because if we do it right, we give people better results, more insight, more time. So again, the idea here is, what if we can set the machines out on sensors and analyze, you know, images and speech or into our data and documents? What if they could detect patterns in anything and act on them? Again, those can be really small interventions. Sprinkle a little machine learning on it, friends. When you consider the pattern matching applications we've looked at, there are really sort of four things that we're able to do now. So let me sort of round those up, is that we can be smarter with questions that we already ask. We can use classification or clustering to understand the conceptual relationships between documents or people or trends. So that thing that we saw with Slack, for example, to be sort of like, this person is associated with these concepts. So we can have better searching, better answers to our questions. But we can also ask entirely new kinds of questions. Right now, we tend to think about asking questions by querying content, by doing a search against text, for example. Instead of keywords, we can ask questions based on emotion. Customer care representatives could queue up emails that have anger or urgency or concern. So entirely new kinds of questions that we're not able to ask right now. We can also unlock new sources of data. So all the messy ways that we communicate as humans through speech and handwriting and video and photos, all this stuff that used to be completely opaque to the machines, they can now make sense of, have understanding, find meaning in those data sources. So how might we tap those as data sources? How much stuff do we have in video content that could be put into video content to be monitored in some interesting way, or for interaction, computer vision, speech UI? How could we use those in new ways? And finally, identify patterns that you never saw. That was the thing that I was talking about with clustering. What happens if you just let the machines loose on these data stores and see what happens? So particularly for UX designers, whose job in general is to figure out what is the problem to solve, but I would say open it up to all of us right now as we're figuring it out, is what are the problems that are worth solving, and how do we point AI at those? So that's what I want to get into here is so how do we work with this? That's the stuff it can do. Those are sort of the opportunities. But how do we understand or identify the opportunities in our product, in our organization, in our personal work? How do we figure out the problem to solve? And then how do we skill up to solve that problem? So in addition to actually designing these machine learning tools, my company, Big Medium, does a lot of product strategy and product invention engagements to help organizations figure out how to use emerging technologies. And we're doing a ton of machine learning work right now. For a long time, it was about figuring out how do we sort of push the frontiers of what mobile can do. And that's really changed a bit in the last couple of years, as now the interesting thing is, well, what can data do for us? What can we do with machine learning? The hard part is often stepping outside of your familiar mindset. New perspective is always required to see new opportunities in new design materials, whether that's machine learning or mobile a decade before. It took us a few years to figure out what mobile was good for. We used to think it was just doing the same old thing smaller and making it mobile, maybe adding a little location to it. But we found actually that there's a whole lot of new design patterns to it too, right? New opportunities for it that we were blind to when it first came out. So sometimes I use games to sort of suss this out. I designed these cards to help executives and makers think through opportunities for machine learning in individual contexts. And there are these white cards that show some kind of activity. I start out with common activities that people might encounter, as civilians, stuff like visiting a foreign country or editing photos, answering email, things like that. And the black cards are just a ton of different applications of machine learning, the superpowers that you might bring to any one of these activities. So the idea is, you say your team draws visiting a foreign country. We do a bunch of thinking about all the tasks and interactions that are involved in it. What are the things that you do when you're doing that? What are the activities and environments and objects and interfaces, the people you interact with? It's sort of a simulation for contextual field research, which you should, of course, do in the context of these exercises. We just sort of huddle and do it as a team. What do people have to do in the course of getting the value and meaning from that activity? And crucially, we try to identify those tasks again that are time-consuming, repetitive, detail-oriented, error-prone, and joyless, because friends, who wants to do joyless stuff? But that's a part of everything, right? So what are the opportunities for the machines to help us with that? So we draw our ability cards to see what we get and think about how the machines could help with a specific problem. Often we sort of shuffle them around and sort of say, oh, now this is an interesting combination. We look at our list of joyless tasks that go into this. And we think about, maybe it's hard to speak a language that you don't know or to communicate. How might I learn that in some interesting or fun way? How could the machines help that or help me to communicate in a way? We shuffle these things around. We say, you know what? If we used camera vision, we could point our phone at something to identify what it is, show that word in English, and then show it in Japanese, and then speak that word in Japanese. And so now I've suddenly turned the entire world into a set of flashcards to help me learn this language, or at least learn simple phrases and words. And again, this is sort of a toy, but as we're going to see, all of these services are available to us effectively on demand for free with very little knowledge. You could build this in an afternoon or in a weekend. So the point of it, though, is particularly to think about how can we match a human need to a machine's skill. So let's use technology in interesting ways, but also let's stay grounded in those real human needs, even as we solve for those. It's a simple exercise that really works. And when I work with clients, we eventually replace those white cards, those everyday scenarios, with various activities that are related to their actual customers and products. So, sort of thinking about that whole customer journey, what are the activities that go in there? And what are the opportunities for machines to step in there? I've worked with clients to come up with, hundreds, maybe thousands of opportunities to improve those kind of customer experiences and business practices with machine learning. Once you've identified those opportunities, you start to dig in. You start to ask questions like, all right, well, we've got the interesting problems here. What data determines the answer to that problem? Who holds that data? And who are the people who we want to serve? How can we make sure that we aren't being overly narrow in where we gather data and introducing a bias that excludes some population of people, and particularly the population of people who we want to serve? You know, it's these questions, these are not specific to machine learning or new technology. These are just good UX questions. The interesting thing, though, is that we now are sort of bringing this to an unprecedented scale, level of data that we haven't had to do before. How do we as UX researchers start to scale up our knowledge and skill for the kind of scale that machine learning requires? We've already seen a bunch of examples of you know, how we might do this, but just as a quick thing, I was doing some work with a healthcare company, and we used this technique to quickly zero in on opportunities to help radiologists do their jobs better. And these are the folks, of course, who examine X-rays, looking for problems. And so much of their time is actually looking at X-ray after X-ray after X-ray, looking for the same or similar telltale signs, finding a mass, determining what it means, what kind of mass is it. What we were able to do is actually get camera vision to do a huge amount of triage for them so that the radiologists could apply their actual expertise, not this clerical work of kind of looking at X-ray after X-ray. The machines could bring the radiologists interesting cases. And of course, you want to dial it down so it's, you know, pretty sensitive. So if anything comes up, you know, you don't want to have any false negatives. But what happened is they took over the time-consuming, repetitive, detail-oriented, error-prone, joyless stuff. It was very successful. So we identified the problem. And now, of course, it's time to actually apply the machine learning. Yay, right? Okay, you guys, let's go. Let's go do our machine learning, except, oh, wait a second, we don't know how to do machine learning. What are you talking about? We're not data scientists. We're not Google up in here. That's okay, though, because for vast territories of machine learning, you can actually get started with very little knowledge or experience in machine learning, certainly to prototype and test your idea. So Google and Microsoft and Amazon and IBM, at the same time that they are in this race to come up with the best algorithms to do all these different kinds of speech recognition, image recognition, all that stuff, at the same time that they're competing for that, they're also competing to give it away. Machine learning services are becoming a commodity just like server hosting. And of course, it's not altruistic. They want more people to give them data so they can improve their models. So these are the kinds of things that, these are interesting services to use to let you prototype things up and running. Up to you whether you want to sort of throw in by building a business on top of them, or building a product that relies on them. But at a minimum, what a great platform to be able to try your ideas and find out if this is sort of something that's worth further investment of building your own models, for example. So as I mentioned, these things are becoming a commodity just like server hosting, and often are given away as part of server hosting. So here's just one example from Microsoft's cognitive services. If you use Microsoft's Azure web hosting, you can get access to these APIs, and Amazon and Google and IBM all have similar offerings, basically free to experiment. Microsoft's a great place to play because they have lots of services that are ready to roll and they're easy to use. So you get tons of APIs here, as you can see, around vision and speech and language, which is essentially sort of how do you make associations and extract key terms from documents, knowledge and search. Just drilling into vision, for example, you see that you can get a ton around computer vision and face recognition and video processing, even content moderation for identification of offensive or adult content. And all the ones marked demo here have a little web interface so that you can run sample data through them and browse the results. And we'll look at that in a minute. But first I want to zero in here on the emotion recognition API, just to give you an example of how easy this stuff can be to use. Emotion API identifies faces and reads their emotions. So here, this guy on the left, he's generally happy, we can see. And by the way, you can see it's breaking it all down into sort of all of the different emotions that we've at some point felt about Microsoft. But this guy is generally, he's pretty happy. He's got some neutral in there, some subtle notes of disgust and sadness. So he's sort of describing stock photography in a nutshell here, really. So way to go, Microsoft Emotion API. But look how easy it is to use. You just feed the service an image, and you get this highly structured data back, usually in JSON. So you can sort of really start to see, oh, these are the ingredients that I could use for a design, or to make associations, or to pass over to the next machine for analysis. So I'll just really encourage you to do this today. Investigate some of these public APIs, because it's these superpowers. They're giving them away. But you can also extend them. Google's got something called Cloud Auto ML, which basically lets you give it your own data to sort of customize their existing model with your own data. So with a very relatively small data set, you can sort of start to tune it for the specific problems that you want. And also Microsoft's custom vision, which is tuned to image recognition, where you can give it your own images and start to train it. So that even small data collections can start to tune their models to your specific needs. There are also a lot of public data sets out there. So turning the corner here, if you do have some machine learning chops, if you have some developers who are familiar with TensorFlow, for example, the technology that Google's open source technology for building machine learning algorithms, essentially. Tons of public data sets out there. I've got some links to some in the links document that Event-Apart provides. And also, you can just build your own model. And there's some tools for that, too, so that designers can contribute to it as well as developers. There's a service called Lobe that's basically drag and drop. So you can train it to see emoji by taking a bunch of photos of people making hand signals and putting those into folders labeled with the emoji. So you're sort of doing these really easy classifications, uploading it, whether those are your photos again, or there's music, there's accelerometer stuff. So basically, you just sort of collect this data, upload it, and it exports this stuff as TensorFlow for Android or Core ML for iOS. And your developers can begin to use these frameworks. So anybody can train the model. It takes some know-how to actually build the algorithm to analyze this stuff. What I'm doing here, though, I really want to encourage you, even if you don't consider yourself anywhere close to a data scientist or a developer, is to get involved with thinking about what is the data that we want to use? Because I think that for too long, that job has been part of a very sort of small, siloed group. And as we're starting to see this kind of data analysis and algorithms touching all the sort of civic parts of our lives, and I'll talk about this in a bit, we're seeing that we actually don't have as broad coverage. We have more blind spots in that stuff than maybe we knew. So the more people who get involved in gathering the data and figuring out what it should be and helping to groom it in this way, the better off we're going to be, not only in terms of the products we make, but I would say in terms of a fair and just society too. So as part of that, as you get to understand is to actually, as a designer, as well as a developer, learn the texture of the model that you want to use. And what I mean by that is actually play with it a little bit. Again, that's one of the reasons that the Microsoft stuff is so great. It's just got a really easy interface for giving it some sample data and seeing what comes back. Because that data those are your ingredients. That's the stuff you're going to be able to build your interface with. So again, if we sort of look in here, we sort of maybe go and we'll take a peek at the image recognition API. You go into that. Here's just like the default image that they give you, just as an example. And you can see it, sort of the data that it gives you. Again, the structured data. It's giving you a bunch of tags. The description here, people waiting at a train station, which is pretty good for this really kind of blurry, kind of crazy image. You see some of the tags here around your train and platform. You also see down here at the bottom the confidence levels that it has for each of these. So it's giving you a sense of how close it believes it is. So as you look at this, again, even as a designer, especially as a designer, I would say, you understand what the thing is good at and how much you can trust its own confidence. Is it sort of like, does the confidence ring true for what it's doing? It's sort of like, yeah, that's not quite right, but it knows it's not quite right. It's like getting a sense for what it's good at, what it's not good at is crucial, because as we'll see, a lot of these things are really about how do you kind of design for failure and uncertainty and the probabilistic nature of this. Designers need to understand the context of this. I, of course, because I'm apparently just like totally self-absorbed, I'm going to go ahead and put my own picture in there and see what happens. See how it does. So it finds, that it's like, oh, all right, the man looking at the camera, that's not too bad. It's not quite got the gaze right, but that's a man in front of a camera. That's pretty good. I was a little, I don't know, you guys. I was a little more worried about this one, I'm not going to lie. I think that one's going to stick with me for a while. Mom. So just Microsoft told me I was. Anyway, it's also a thing that you can go in. It's like it added a good 7 years on there. It's just like I'm just like I got to say, Microsoft not make me feel good about this. I'm glad I looked at the model. This is a terrible model, you guys. And do not use any of the Microsoft stuff. Obviously, does not know what it's doing. Which, in addition to sort of looking at the texture of it, of actually digging in and sort of seeing what kind of data comes back. What are the results? How is it structured? What are the ingredients I can use to illustrate confidence or to what kind of content can I provide, machine-generated content? It's also to think about the right data set. Kate reminded us that there's some hard problems in image recognition, that sometimes it's a little bit hard to see exactly which one is which. I'm going to challenge you guys a little bit with this next one, all right? I want you to brace yourselves, because it gets a lot harder than chihuahuas and muffins. And I just want to say this stuff is hard work. It's like these are the kinds of deep sacrifices we have to make for the future, is to look at this stuff. But as Kate mentioned, this one is a classic. This is sort of like a trope of the AI community. So some friends of mine in New York at TopBots decided to say, wait, let's see how the off-the-shelf APIs are at dealing with this problem. Let's see how they do. And so they took a whole bunch of them, recognition from Amazon, Microsoft Service, IBM Watson, Google, CloudSight, Clarify. And you see actually in here that there's a good bit of food recognition in here. It's Amazon sees this as bread and dessert, and Microsoft actually sees a stuffed animal. Microsoft sees stuffed animals in a lot of places, it turns out, as you look at this. In fact, it's like, here we go. Like, all of these things are stuffed animals. The first one there, a brown and white teddy bear. Which is interesting, right? Because it suggests here's the stuff that the Microsoft model knows, probably trained on sort of household, familiar objects. It's not as good at sort of food stuff. So just, it's not a one-size-fits-all thing. All of these models they know the data that they were trained on, which is sort of one of the real characteristics and textures of machine language generally, but one that you really sort of need to investigate. Again, as a product owner, as a designer, and as a developer, what is this good at, and is it good with our data? Or and is there a possibility to train it to improve using some of the services I mentioned already? Or do we need to go someplace else? But really broadly, what we're talking about is our job is really designing content and interactions that are out of our control, that are going to be coming back from the machines. And so we have to have a really sharp understanding of what the uncertainty and constraints of that system are. How are we going to design to them and around them? It takes a human about 14,000 brain hours to learn to run. And it turns out that an AI, a machine learning system, can figure out how to run, at least sort of manipulate a digital model to run in less than half as many CPU hours. But the results, talking about kind of constraints and uncertainty, come out like this. And what it's doing, it's using its arms for locomotion. It's kind of ignoring kind of all these it's ignoring sort of the inconvenient parts of like the fact that we have rotator cuffs that can tear, and the fact that this requires a huge amount of energy up here to sort of do this. But in this sort of frictionless environment, it works great. So the machines come up with what I would say very unorthodox answers to problems sometimes. Now, in fairness, people do too sometimes. People do sometimes come up with their own unorthodox motion techniques, as anybody who recalls Prancercise of the 2012 era may know. Not all that different, right? So the thing is that people are unpredictable and eccentric. So how can we expect the machines always to make sense of what's happening in the same way that sometimes we have trouble understanding them? And that gets at some important pieces about the nature of machine learning. So let's switch into our third chapter to talk about the grain of machine learning. What I mean are, in terms of the unique qualities of this design material that give us cues in how it should be used. It's what is the sweet spot there? And there are a few different aspects to it. And the first, and we sort of just touched on this a little bit, is the machines are weird. They come up with answers that we don't always expect. Not exactly mistakes, but a lot of misunderstandings or strange perspective. So if we ask Siri, for example, hey Siri, how long can a lobster survive out of water? It comes back with a very precise answer, which is 3.23 times 10 to the negative 7 years per mile squared. You sort of look at what's going on here? Well, it says it's lobsters. If we say, remember the question, how long can a lobster survive out of water? So how long can a lobster survive? Here's the maximum lifespan of a lobster. Out of water. It's understood that like a math question. So out of water means divided by water or over water. So here we have the world's total surface area, right? So unassailable logic. How long a lobster can survive out of water? Its perception was great, the speech recognition was perfect, but it totally misunderstands the question, right? Other times it's the perception that's garbled. Where you've got something here, it's like, great, all right, the doorbell is supposed to recognize lock when it doesn't recognize somebody, and so it locked, and he goes in and he finds, oh, wait a second, there's a new person here. Do you want to let this one in? And the system says, no, that seems kind of crazy. So the point here, right, is that we really need to design for failure and uncertainty. The more that I work with machine-generated results and machine-generated content, machine-generated interactions especially, the more that I realize I'm not in control of that experience as a designer, and that's new. We're used to designing paths through fixed sets of information under our control. We're used to designing for success, for the happy path. And now we have to anticipate this fuzzy range of results and confidence. And that's why it's so important to understand that texture, the strengths and weaknesses of the model as we saw before. But our challenge now is really to set expectations, to channel behavior in a way that matches up to the system's ability and kind of be gentle when there's a mistake. And so how do we do that? Well, friends, of course, the answer is BASAP, which we all know stands for be as smart as a puppy. So this is a phrase from Matt Jones of the late great digital agency Berg London, which is a pioneer in connected devices and digital weirdness. And he came up with this way to think about creating honest, gentle interfaces for our systems. And the idea is that our goal should be making smart things that don't try to be too smart and that make endearing failures in their attempts to learn and improve, like puppies, or like robot soccer players.
Elusive. Can it contain him? Snapping ankles along the way.
Run again! This run is uncontainable!
Adorable. I mean, the right manner helps us to anticipate and forgive and recover from error. It may sometimes be annoying, even puppies are annoying, but it won't surprise us or at worst endanger us. Because a little bit too often, the experience looks a little bit more like this when a system fails, right? Yeah. So the point is the interface that we create, the way that we present these systems sets expectations. And our job is to set appropriate expectations and channel behavior in ways that match the system's ability. Robots used to look like this. And all they would say is things like, does not compute, danger, danger, right? That's it. And that gave us an important cue of what we could expect from them. In a way, Alexa and Siri and Google Assistant, they all overpromise. They front as nearly human assistants, and they invite us to ask them anything. And as capable as they are, they set expectations that they can't possibly fulfill. They'd be better off with BASAP, be as smart as a puppy. Sort of the second part of the texture that I want to talk about is just narrow domains. The systems that we create, just like they know very limited amounts of things. So CycleGAN is a tool, a neural network that's trained on pictures of horses or fruit and taught to transform them. So a picture of apples becomes a picture of oranges, or boom, your horse is a zebra. But if you show it something that it doesn't quite understand or recognize, it'll just sort of fold it into everything else that it knows, right? So there are a few bugs here. If it only knows horses, everything is a horse. It's a narrow problem. And of course, this isn't real intelligence, nor is it real expertise. And I think that that's an important thing to recognize, both in terms of how you're going to use it, and also in terms of how afraid you ought to be of this stuff, which I would say is not very. Benedict Evans puts it this way, that this gives you infinite interns, or perhaps infinite 10-year-olds. And the idea is that 5 years ago, if you gave a computer a pile of photos, it couldn't do much more than sort them by size. A 10-year-old could sort them into maybe men and women, a 15-year-old into maybe cool and uncool. An intern could say, hey, this photo is interesting. Right? And today, machine learning can maybe match the 10-year-old and maybe the 15-year-old. So what would you do if you had 1 million 15-year-olds look at your data? I mean, that's probably a terrible idea to do actual 15-year-olds on that, but there you go. What might they find, though, in some narrow domain? I want to say it doesn't have to be narrow, as we do this, as we solve narrow problems. And that's the way to think of it. It's like, what is this really constrained problem set that we can focus on? They don't have to be small problems. They can be important ones. We saw that radiology example. They can be meaningful. They can be things that help us just a little bit, save us a few seconds in our day, or they can be things that really help people be more creative and really zero in on the stuff that they're doing. The thing is about some of these things, though, as they sort of find these systems, we don't always understand how they come to the conclusions that they come to. And that's another part of the grain of machine learning, is the fact that they have this really opaque logic. So here's a ridiculous example about me, the elephant. Spotify. So you guys discover playlist. You use this? Whenever I listen to it, it sounds a little bit like this. I am deeply uncool, right? I wish I was cooler. I'm embarrassed by it. Apparently, I care what their algorithm thinks of me, though. So more to the point, I don't like the reflection I see in Spotify's musical mirror. So I skipped the music that I'm afraid Spotify will judge me for. But also, I'm sort of afraid to skip because it's like, will I never hear that song again if I skip it? Because I kind of deep down secretly love it. So my mental model of how it works changes how I behave. But I'm also not sure if my mental model is correct, so I wind up kind of paralyzed. The system is opaque. So I think the thing that we really need to do is to help people to form a useful mental model here. Part of our obligation is to create data literacy, to help people understand how the internet works now, as well as our specific services. So the interface should give explicit feedback to indicate how fast forwarding a song is affecting your profile. Just a little, some kind of indicator that gives you a hint. It should show how the Discover playlist is associated to songs that you've listened to recently. This also could turn into a really fun opportunity, or in my case, a deeply embarrassing one, to explore your own taste. So the idea here is that we really need to signal our intentions and reveal our actions and be transparent, and particularly in the way that we are using data, of course, something that I would say is obviously a huge problem in our industry. Facebook, Google, excuse me. Because it's especially if you're sort of taking data and you're like, oh yeah, we should probably tell people about that. It's like, well, people might not sign up for our service. If you think people don't like it, you probably shouldn't be doing it, right? Let's make this transparency a default design principle. Another thing I want to mention is that machine learning is probabilistic. And what that means is machine learning sees the world in shades of gray. Nothing is fixed. It's all probabilities. We saw that in those confidence scores that we saw. Its algorithms are really explicit about their confidence in their predictions. And we see it in Netflix and their recommendation engine. They surface that. Here's 72% confidence. What I've seen, though, in usability studies is that sort of showing these kinds of confidence numbers, they aren't actually always well absorbed or understood. They don't hold much meaning. So they tend to be glossed over. In an application like Netflix, the stakes are pretty low, but there are other places where the stakes are much higher, where it's really important to understand the confidence that we have. Law enforcement starting to use face recognition algorithms, the very same ones that we were talking about here before, for pattern matching, for predictive policing, to pluck suspects out of the wild, and that's pretty serious. Are the machines up for it? ACLU did their own thing and ran Congress through a set of 28,000 mugshots and apparently confirmed with science that Congress is a bunch of crooks. Actually, though, these were mistakes, of course, right? So if we look under the hood, the ACLU left the setting to the default, which declares a match when there's 80% or better confidence. And Amazon said, whoa, that's not fair. We tell police departments to use at least 95% confidence, although the default for the system is 80%. It's a probabilistic tool. But in a way that makes the ACLU's point, which is that the machines require careful tending. Those of us close to the machines need to understand how confident they actually are. But we also need to make that transparent to the users and the civilians who get those results from us. So I think that a really important thing to recognize here is that I don't know is actually a better answer than the wrong answer, especially in really important and potentially dangerous things like this. So the idea here is that we shouldn't present our information as absolutes, as binary, of this is the answer, although our industry is really primed to rush to an answer in many cases, but as signals. Hey, there's a strong signal that this is something that you should look at. And I think that one of the challenges there is that we need to sort of think about how can we encourage people to think harder about an answer, to engage their critical thinking, rather than just to accept what's there, what kind of comes in. Because this is another thing, is that the machines tend to reinforce normal. And we talked about that in a sense of clustering. It's like, oh, here's are the things that depart from normal. Or this is predicting the next normal thing. But the problem is, if normal is garbage, what then? What if the data is problematic? And sometimes that data just comes from our flawed history. Let's not codify the past. This is a phrase from the data scientist Cathy O'Neill in her excellent book, Weapons of Math Destruction. On the surface, you'd think that removing humans from a situation might eliminate racism or stereotypes or any other very human bias. But in fact, the risk is that we bake our history, our past history, into our data and into the very operating system itself. And so in the case of predictive policing or sentencing algorithms where the data is so completely biased against black men, or hiring and promotion algorithms where the historical data favors white men and is biased against women and people of color, that data bias codifies that ugly past. So here again is an opportunity for us to think about these of sort of like, where is the data? Who are the people to serve? Are we using the right data? And sort of help that to sort of figure out where should we point the data scientists and the algorithms and their weapons of math destruction. The last thing that I just want to bring up here is just to think about as we do this, and this is sort of really getting into it, is how do using these systems affect us? And not just in the way that we're seeing here, where biased data could give us bad information and make bad choices, or do us even personal harm. But how do they change our behaviors as a society? What is it going to do as we start to use these? What is it going to do to us as designers and developers? I think the first thing to sort of recognize is this sort of important idea from the middle of the last century from Melvin Kranzberg, a historian of technology who had several laws of technology. And his first is just this, that technology is neither good nor bad, nor is it neutral. And the good and the bad sort of talks about intention. We might have good intentions or bad intentions as we use it. And so that's a big part of it. But the thing, nor is it neutral, is often that we don't have any idea what the effects of using this thing will be. I think Facebook in particular is sort of reaping what it's sown there, sort of understanding that it's had effects well beyond what they ever intended as they built their super ad machine. But the thing is that we have to give it a good go, and we have to think about those secondary effects, because if we don't decide for ourselves, the technology will decide for us. It's the case of the tea kettle, holding Mark Rittman's family hostage all day, right? Working hard to restore the network just to normalize their life and keep the kettle happy. It feels like this a lot of times, right? That too often our lives bend to the needs of technology instead of the reverse. Most of us do this daily on the web, training Google's reCAPTCHA tool how to identify stop signs and crosswalks in cars, right? By selecting multiple boxes that contain those things. And now it's leaking into the real world. The tropes that we impose in the digital world affect us everywhere, right? So now it's just like, yep, that's right, I'm not a robot, just to buy my car. So, and this is sort of the nature of things. I think you probably find this as you talk to speech recognition systems, as you talk in sort of a new stilted language, try to use its vocabulary to help us be more like them. The more we talk to robots, the more we talk like robots. I'm a big fan of technology that empowers us to do more and to be more human and to make human connection. Building stuff out of an unbridled enthusiasm for technology, of building juicers that aren't needed and kettles that won't connect. These things tend to make us feel trapped. So as we think about what are the opportunities for diving into new technologies, what are those creative opportunities, what are those business opportunities? let's first take a look at what are some of the after effects that we're going to be doing, and are we solving real problems? Because a lot of the problems that we solve now feel like we're sort of infantilizing people. We're sort of replacing their moms, we're bringing them dinners, we're doing their cooking, instead of maybe helping them cook healthier meals. It's a subtle but important distinction. Instead of sort of taking things off your table that are creative and meaningful, how can we actually empower you to do those things better? So instead of hijacking our agency, how can we augment our judgment, amplify our potential by doing that joyless work for us and delivering new insight from it so that we can be more creative and more insightful and more compassionate? Because friends, we are making this up, we're making it up, literally, figuring out how this works together. Nobody knows what they're doing yet, but the stakes are really high because the possibilities are so powerful. These tools are so powerful. I think that we can use them to make people's lives better and more creative. And this new design material is ready to use right now, and tools that are available to you with the skills that you already have right now. So I encourage you to dig into them and start thinking about how you can apply them. And thinking about some really interesting and new and heretofore invisible patterns that you can apply. Really bring some wild ideas to this. Put that to work again in small interactions or in audacious projects. Again, the tools are here for you now to make something amazing, so please do that. Please make something amazing. If you're interested in more on this topic, I want to encourage you to take a look at mindfultechnology.com, which is sort of a think tank about how do we create products that focus attention instead of distract it. The UVET agenda, which is part of the output of a retreat that I and a whole bunch of science fiction writers and designers and researchers, academics, looked at from sort of a humanistic perspective to what are the questions that we need to ask of machine learning and artificial intelligence. And then my own site, bigmedium.com, where you can find out more about this. And of course, I'm happy to help you too. My company helps organizations figure out how to use emerging technology in meaningful ways. So give me a shout if I can help your organization. In the meantime, I think that there's just really one last piece of business, one last thing that remains to be said.
So let's stop talking and do some walking.
Thank you very much.